Now, you will notice that the spiral count that we have talked about so far with the pineapple and the coneflower has produced the numbers 8, 13, and 21. Okay? Well, let's go on and let's take a look at another flower. Okay? Here is a daisy. Now you can see there are spirals in the seed pods of the daisy as well. Well, if I were to try to count these for you right here now, okay, it would be pretty difficult for me to do it. I would mess it up. So I have already taken pictures of the spirals, okay, so I'll show them to you now. Going in one direction, if you count those number of spirals that occur, we have 21 of them. Okay, if you go to the spiral direction the other way, all right, you find there are 34 spirals that emit from the center of the flower. All right, so what's our seed pod count now, or our spiral count now that we've developed so far? Well, you notice the 21 was in the coneflower. All right. It was also in the daisy here, right? And then, of course, we had 34, which gave us the 34 for the daisy. Do you notice anything about those numbers? Did you maybe notice that if you add 8 and 13 together, you get 21? And if you add 13 and 21 together, you get 34. Now, remember the number sequence problem I talked about in the very first day of class? We saw that there was a number series or sequence that I put as an answer to a question, and you noticed that you could continue this process along forever, okay? Well, you know what? Let's try something weird. Let me see if I can mess this one up for you. Look at this pine cone. Now, if you look at this pine cone, you can see some spirals on it, right? So, not only that, if you pick up an acorn and you look at the top of an acorn, you can see spirals in it, but I have never been successful at counting the number of spirals in the top of an acorn. But sometime when you're out, pick up an acorn and take a look at it, and you'll see there are spirals in that as well. What I'm going to do is try to look at the spirals in this pine cone. And sometimes I mess this up pretty well, so let's see if I can avoid messing it up. I can see some spirals very easily right now going this way. There appears to be one coming down like this. 2, 3, 4, 5, 6, 7, and I believe there's one there. So it appears we have 8 spirals running in one direction on the pine cone. All right. Now, let me go to a different color and let's do the spirals the other way. All right. So let's see. I can see a spiral definitely here. It appears, and hopefully I'm not messing this up, there's one here. Appears to be one there, and one definitely there. Now, it appears that I have in red 5 spirals, right? And in blue, I think I have 8. 1, 2, 3, 4, 5, 6, 7, 8 of them. Guess what? If you take a look at what the author talks about in his videos that I'm not showing right now, notice the numbers 5 and 8 show up on the pine cone. And notice they fit the same sequence. If you add 5 and 8, you get 13. 8 and 13, you get 21. 13 and 21, you get 34. Now, the mathematician that is noted for having kind of discovered this material and put a name to it was Fibonacci. This sequence of numbers is known as the Fibonacci sequence, and we are going to do a lot with the Fibonacci sequence over the next several classes. In fact, right up almost to the very end of the course. So the Fibonacci numbers are abounding in nature, okay? And these series seem to show up everywhere, okay? Now, here is actually the Fibonacci series going way back to the two numbers that are called its starting seeds, 1 and 1. So the first Fibonacci number is a 1, and the second Fibonacci number happens to also be a 1. But notice, if you add 1 and 1, you get 2, 1 and 2, you get 3, 2 and 3, you get 5, 3 and 5, you get 8, and so forth. And this can continue on to infinity. So this is the famous Fibonacci series. Okay, now, what else can we discover about the Fibonacci series? All right. Well, look, if you take the Fibonacci series and you kind of look at it, if you look at the number 3, it's not quite 2 times 2, the number before it, right? So in other words, if I go to the number 3 here and I look at the number right before it, 2, if I double 2, I get 4. If I subtract 3 from 4, I'm off by 1, right? Okay, let me erase those so that we don't get confused here. All right, if I go to the number 5, which is the next number here, I look at the number before it, it's a 3. If I double 3, that is a what? That is a 6. And of course, 5 and 6 are only 1 apart from each other. So notice I have 1 here and 1 here. All right, let me erase this again so I don't confuse this. If I go to the number 5, all right, and I double it, notice I get an 8, right? I get an 8. Before it was a 5. If I double 5, right, that's 10. What's 8 taken away from 10? It happens to be 2. And notice I can continue this. If I double 8, all right, you get 16. 16 is 3 away from 13, the next Fibonacci number, right? And if you do the same thing on the next one, if you double 13, you get 26. 26, if you subtract 21 from it, you get 5, right? Notice, what am I producing again? I'm producing the Fibonacci sequence all over again, okay? Just using a different method to get it, all right? So start with the Fibonacci number, take twice the previous number and subtract the starting number from it. The difference will produce a Fibonacci number. Crazy, huh? Crazy. All right. Now, this is just showing here also the same concept, except it's a little different. Is there another way to generate this series besides adding 2 numbers together to get the next one? Well, look at this one. If I take the Fibonacci number 13, okay, and if I multiply it by 2, I get the 26 that's right there, right? If I go back 2 Fibonacci numbers prior to it, to the one I started with, the 13, that's a 5. If I subtract 5 from 26, I get 21, which is the very next Fibonacci number. Okay? Now, let me go over here. Let me go back here to the series all by itself here, there. All right, let's see if that works again. All right? If I take 34 and multiply it by 2, I get 68. If I go 2 numbers prior to the 34 I started with, that's 13. If I subtract that 13 from the doubling I got of 34, which was 68, look what I get. 55, which is the next Fibonacci number. So there are all different kinds of ways that you can kind of mess around with this series of numbers, and these neat relationships seem to exist. I know you're thinking to yourself, Mr. Kelly, get a life, okay? I mean, come on. This is exciting to you? Well, I think it's kind of cool. And these numbers do some neat things. And they're neat things that I didn't see till I was into my 60s. I never knew Fibonacci numbers even existed. As a matter of fact, if I had a recommendation to make to middle school and high school teachers, we need to teach the Fibonacci series to students so they can be aware that it's all over nature and they should know about this. So guess what? You know about it. You can pass it along to your children if they don't get it in school. You can teach them how the Fibonacci numbers work when you become a parent and you have your own children. How about that? Okay? All right. So let's go on here. So we've taken a look at this new Fibonacci series. Now what I'd like to do is say to you that we can use the Fibonacci pattern to create any series we would like to using starting seeds that we choose. Notice we are having starting seeds here, the first two numbers of 2 and 1. Notice they're backwards, but that's okay. All right? These are called Luca numbers. When you do a series that's called the Luca numbers, you start out with 2 and 1. And you take 2 and 1 and add it together and get 3. You add 1 and 3 and get 4. 3 and 4 to get 7. 4 and 7 to get 11. 7 and 11 to get 18. 11 and 18 to get 29, and so forth. And this series goes on to infinity. We could do this all day, all right? So these are called the Luca numbers. I'm sorry, I didn't do that right. Luca numbers. The numbers we have dealt with just before this is the Fibonacci sequence, okay? So these are kind of cool things that happen with these numbers if you develop them using the same pattern we used in the Fibonacci series. Okay, let's look at some turning point type questions. The reason I call them TP questions is if you were in my regular class, we would do all of our video quizzes on these little clickers called turning point clickers. And you would answer the questions A, B, C, D, or 1, 2, 3, 4, and 5 by using a clicker. All right. Well, of course, we're not meeting together in a live classroom setting, so I can't use the clickers to test you. So I have to have you send me your answers to these various quizzes. By the way, this is not a quiz. All right. We're just going to go over these numbers together to get a better feel for the Fibonacci sequence. Now, I want you to look down at the bottom. At the bottom, I have produced a table. The N on top, the N that you see right here circled in blue, is the location, right? Is the location of the number in the Fibonacci series. So in other words, the 13th number in the series is 233, right? The 17th number in the series is 1597, okay? So that's what the N stands for, is its location in the list. And of course, down below, F sub N means the F sub N, and as a subscript, it simply says that if you use the N up above, you will get the right or correct Fibonacci number. So these are all the Fibonacci's listed up to 2584. Now it says here, if F sub N is the Fibonacci number 89, then what would the value of the subscript N have to be? Well, if you look at the number 89, I'll show it to you in red right here. It is in what position? The 11th position. So it is referred to in notation using subscripts and the capital letter F. It is referred to as F sub 11. So the correct answer for this is choice 2. So F11, in other words, the Fibonacci number in the 11th position, all right, of the series is 89. No problem, right? Let's go on. If F sub N exists such that N is 16, then the Fibonacci number's value, which corresponds to F sub N minus 7, is what? Now, wait a minute. Let's write that down. F sub N minus 7. We already know we're using n as 16. So what I've got to do is I've got to put that 16 in the place of n for that subscript. So it's going to be f sub 16 minus 7. Well, let's just subtract 16 and 7. What do we get? We get f sub 9. So the ninth Fibonacci number then in the series is the number 34. So f sub 9 is 34, okay? And f sub n minus 7 is also 34 because we're putting 16 in the place of n. The reason we like to teach you this stuff is we like you to get used to subscript notation. You're going to run into subscript notation a lot in your life, and we might as well get used to it in Math 103. So that's why we teach this and develop it with you. All right, let's go on. If f sub n exists such that n is 12, then the Fibonacci numbers value, which corresponds to f sub 2n minus 9, is what? Well, f sub 2n minus 9, I've got to put the 12 in there for n. So 2 times 12 is what? 24. And I subtract 24 minus 9, I get what? F sub 15, right? So I go down here, I look, and f sub 15 is the number 610. Okay? But I had to evaluate the subscript in order to find the correct number that represents that location in the Fibonacci sequence. All right, let's look at D. If f sub n exists such that n is equal to 3, then the value of n, or f sub n notation, which correctly represents the Fibonacci number 2584, is what? Well, look at 2584. It is the 18th Fibonacci number, right? So f sub 18 is 2584, right? Okay, if I want n to be 3, okay, in my subscript, I want n to be 3. What do I have to do to 3 to make it become 18? I'd have to multiply it by 6, wouldn't I? So f sub 6 times 3, or f sub 18, is 2584. So my correct notation that I would have to use so that my subscript would come out correctly 18 would have to be what? F sub what? 6n. Because when I put 3 in for n, 6 times 3 is 18, f sub 18 is 2584. I hope you're catching on kind of to how this is working, okay? All right, let's go on. If f sub n exists such that n is 5, then the value of the Fibonacci number, which is represented by f sub 4n minus 3. Well, all I got to do is put the 5 in for n in the subscript there. So I'll go f sub 4n minus 3, f sub 4 times what? N, which is 5, and I will subtract 3. Well, your order of operations, of course, tells you you have to multiply the 4 and 5 first, which is 20, and 20 minus 3 is 17. So the number we're looking for is f sub 17, okay, which is 1597, which of course is choice number 4. Okay, now what I'm going to ask you to do is this. I'm going to ask you to complete right now video quiz 4. Okay, so I have sent that to you. VQ4 was sent to you. All right, and I want you right now to take out video quiz 4, write down what the answers are, A, B, C, D, or E, or whatever they might be. Okay, the letters of the answers down, and please text them to me. You just send me a text and say, VQ4, and you write down what the answer is for 1, 2, 3, 4, and 5. Okay? All right? So I'm going to stop this video at this point, and I'm going to ask you to do the video quiz. You don't actually have to print the video quiz if you don't want to, because you can just look at it on your computer screen or on your iPad screen, okay, or even on your phone, because you can download it from my email. All right, it's an attachment, and you could just see the quiz and just go through it and write down the answers. So you don't actually have to show me any work. You just have to show me what your answers are. So with no further ado, I am going to stop and let you take video quiz 4. Okay?